How does one of the founders of modern American rocketry become one of the strangest figures in scientific history? Long before NASA existed, one man helped lay the foundations of American solid rocket propulsion. By day, he designed rocket fuel that transformed what solid rockets could achieve. By night, he performed ceremonial rituals in search of hidden spiritual forces. History remembers the astronauts who reached space. It has almost forgotten the man who helped make it possible. He never earned a university degree. Yet the technology he helped pioneer became a defining pillar of American astronautics, shaping everything from military missile programs to the space shuttle that would carry astronauts into orbit for 3 decades. As a teenager in the late 1920s, while much of the scientific establishment dismissed practical space travel as fantasy, Jack Parsons was quietly teaching himself how to build rockets. Inspired by the pages of pulp science fiction magazines, he refused to accept that the impossible should remain impossible. But rockets were only one of his obsessions. Outside the laboratory, Parsons became consumed by ceremonial rituals. He believed that science and esoteric spirituality were not opposing worlds, but different paths toward discovering hidden forces that governed the universe. To him, the laboratory and the altar served the same purpose, unlocking powers that others either failed to see or were too afraid to pursue. By the time the space shuttle first thundered into the sky nearly 3 decades later, the man who had helped make its solid rocket boosters possible had largely vanished from public memory. This is the story of the forgotten visionary who helped ignite America's journey into space, and of the extraordinary life that almost erased his place in history. The road to modern rocketry did not begin with a breakthrough. It began with explosions. By the early 1930s, Jack Parsons and a small group of young enthusiasts had become regular fixtures around the Guggenheim Aeronautical Laboratory at Caltech. Every experiment seemed to end the same way. Rocket motors exploded, casings ruptured, windows shattered. On more than one occasion, the team narrowly escaped serious injury. To the established scientists watching from a safe distance, they weren't pioneers. They were a danger to themselves and everyone around them. Before long, the group earned a nickname that would follow them for years: the Suicide Squad. For safety, their increasingly hazardous experiments were pushed away from the Caltech campus and into the barren Arroyo Seco, a dry canyon on the outskirts of Pasadena. Far from lecture halls and faculty committees, the canyon became their laboratory. With little more than improvised equipment, stubborn determination, and an open sky above them, the Suicide Squad continued chasing a dream that much of the scientific establishment still regarded as fantasy. The engineering problem confronting them was immense. Existing solid propellants burned unpredictably, often destroying the very rockets they were meant to power. Liquid fuel engines promised greater performance, but demanded a bewildering network of pumps, valves, and plumbing that made them extraordinarily difficult and dangerous to operate. Rocketry wasn't short of ambitious ideas. It was short of a practical way to make them work. Most engineers searched for better machinery. Parsons believed the breakthrough lay elsewhere. Unlike many of his contemporaries, he had never inherited the assumptions about what couldn't be done. He saw propellants not as passive chemicals, but as something that could be fundamentally reinvented. To Parsons, chemistry was not merely a supporting discipline. It was the key that would unlock practical rocketry. If the fuel itself could be transformed, the rocket could be transformed with it. Their unconventional experiments caught the attention of one man who saw promise where others saw recklessness: Theodore von Karman. One of the world's foremost aerodynamicists, von Karman recognized that behind the explosions was genuine engineering talent. Rather than shutting the young experimenters down, he brought them under the protection of GALCIT, the Guggenheim Aeronautical Laboratory at Caltech, giving them the institutional support to continue work that few others believed had a future. There, the partnership that would define the group's success began to take shape. Frank Molina, the disciplined engineer and mathematician, supplied the calculations and scientific rigor. Parsons supplied the chemical intuition and relentless experimentation. Together, they began transforming rocketry from an improbable curiosity into a legitimate field of engineering. By the end of the decade, the explosions had become less frequent. The failures had become lessons. What had begun as a handful of outcasts experimenting in a dusty canyon was steadily evolving into America's most ambitious rocket research program. The next challenge was no longer proving that rockets could work. It was building a propellant powerful enough to change history. By 1939, the shadow of World War II had transformed the impossible into a military necessity. Aircraft were becoming heavier, runways shorter, and the demand for rapid takeoffs greater than ever before. The military had little interest in elegant engineering solutions. It needed thrust that was reliable, compact, and immediately available. For the first time since the First World War, the United States government invested in rocket propulsion, awarding the GALCIT team a modest $1,000 grant through the National Academy of Sciences. It was a tiny sum, but it marked the beginning of something far larger: jet-assisted takeoff. The engineering challenge remained formidable. Most engineers searched for better rocket engines. Jack Parsons searched for a better fuel. His genius lay not in mechanical engineering, but in chemical intuition. Parsons realized the breakthrough wasn't building a different rocket. It was reinventing what burned inside it. Working through countless experiments, he developed a castable composite propellant by combining potassium perchlorate, a powerful oxidizer, with asphalt, a thick, viscous binder. Instead of packing loose propellant into a casing, the mixture could be poured directly into the motor and allowed to harden into a single solid grain. That seemingly simple idea changed everything. By casting the propellant as one continuous block and shaping a hollow core through its center, Parsons could precisely control how the fuel burned. The flame front advanced smoothly from the inside out, producing a predictable and sustained release of thrust, instead of the violent pressure spikes that had plagued earlier solid rockets. What had once been an unpredictable explosion had become a controllable engine. It was one of the defining breakthroughs in the history of rocket propulsion. The principle Parsons pioneered, castable composite solid propellant, would later power generations of American missile systems, and decades later, the enormous solid rocket boosters that lifted the space shuttle from its launch pad. In August 1941, the theory faced its ultimate test. The team mounted jet-assisted takeoff units beneath an Arco Ercoupe aircraft. As the boosters ignited, the aircraft surged forward with a force no conventional engine could match. During one demonstration, the propeller was removed entirely, allowing pilot Homer Boucher to fly using rocket thrust alone. The Suicide Squad had proven that rockets were no longer laboratory curiosities. They were practical machines. The United States military responded immediately. To manufacture jet-assisted takeoff units on an industrial scale, Parsons and his colleagues founded Aerojet in 1942. Military orders quickly followed, and within a year, thousands of rocket boosters were being produced for Allied aircraft operating from short Pacific Island airstrips and crowded aircraft carriers. The experiments that had once shattered windows in Arroyo Seco were now helping launch the American war effort. The transformation was equally profound back at Caltech. What had begun as a handful of young outsiders experimenting in a dusty canyon had grown into a permanent national institution. In 1943, GALCIT's rocket project was formally reorganized as the Jet Propulsion Laboratory. JPL had been born. The canyon that once echoed with explosions had become the birthplace of America's rocket future. By the end of the Second World War, Jack Parsons stood at the height of his career. He had helped solve one of rocketry's greatest engineering challenges, co-founded one of America's most important aerospace companies, and played a central role in creating the laboratory that would one day send spacecraft across the solar system. He had achieved everything he had dreamed of as a boy reading pulp science fiction. He had no idea that his greatest achievements were already behind him. By the end of the Second World War, Jack Parsons had achieved what few ever could. Yet, just as his professional life reached its summit, his personal life began drifting towards something far stranger. Years earlier, Parsons had sold much of his stake in Aerojet for a fraction of what the company would eventually become worth. Flush with cash but lacking long-term financial security, He purchased a sprawling 19-room mansion on Orange Grove Boulevard in Pasadena. He called it the Parsonage. It quickly became one of California's most unusual households. Scientists, artists, writers, musicians, and mystics moved through its doors in a constant stream. Conventional rules held little authority there. Parsons embraced a radically bohemian lifestyle, believing that personal freedom, scientific discovery, and spiritual exploration were all expressions of the same fundamental force, human will. Life inside the parsonage was as unconventional as its owner. Parsons initially lived there with his wife, Helen, and her younger sister, Sarah Northrup, who had become deeply involved in the household's spiritual community. As Parsons' marriage unraveled, his relationship with Sarah grew into a romantic partnership. By the time the rituals began, Sarah was no longer simply a member of the household. She was Parsons' closest companion and fellow believer. His greatest obsession had become the teachings of Aleister Crowley. Having risen rapidly through Crowley's Ordo Templi Orientis, or OTO, Parsons became one of the organization's most devoted members and its principal financial supporter in America. To Parsons, ceremonial ritual was not superstition. It was another form of experimentation. Just as chemistry sought to uncover the hidden laws governing matter, he believed ritual could reveal the hidden forces governing consciousness itself. Then, in 1945, another science fiction writer arrived at the parsonage. His name was L. Ron Hubbard. Charismatic, confident, and endlessly persuasive, Hubbard quickly earned Parsons' trust. Parsons believed he had finally found someone who shared both his intellectual curiosity and his spiritual ambition. Together, they embarked on what became known as the Babalon Working, an elaborate series of ceremonial rituals intended to invoke the goddess Babylon into the physical world. For weeks, the parsonage became consumed by the working. Parsons and Hubbard carried out lengthy invocations, symbolic rites, and intimate ceremonial practices drawn from Crowley's teachings. Parsons documented every stage with the same meticulous attention he had once devoted to rocket experiments, convinced he was conducting a genuine exploration of forces that conventional science had yet to understand. Then, as though answering the ritual itself, a young artist named Marjorie Cameron walked through the front door. To everyone else, she was simply another visitor. To Parsons, she was proof. In Cameron's striking red hair and fierce personality, he believed he had found the earthly manifestation of Babylon herself. He became convinced that the working had succeeded, that the barrier between the spiritual and physical worlds had been breached. Even Crowley was alarmed. From England, reports of the rituals reached the aging occultist through letters from senior members of the OTO. Rather than celebrating Parsons' apparent success, Crowley dismissed the working as reckless and questioned Hubbard's motives, warning that Parsons was allowing enthusiasm to overwhelm his judgment. Even the founder of the movement believed his most devoted disciple had gone too far. While Parsons devoted himself to Cameron and his new spiritual mission, Hubbard grew increasingly close to Parsons' partner, Sarah, and began a relationship with her. Hubbard and Sarah disappeared together with more than $10,000 of Parsons' savings, an enormous sum at the time, and traveled to Florida, intending to purchase yachts and begin a new business venture. When Parsons discovered the betrayal, he pursued them across the country. In one of the most extraordinary episodes of his life, Parsons later claimed to have stood on a Florida shoreline, performing a ceremonial ritual, calling upon supernatural forces to prevent Hubbard's escape by sea. Soon afterwards, a violent storm drove Hubbard's yacht back into port, allowing Parsons to obtain a court order recovering part of the money. The man who had helped build America's rocket industry had lost much of the fortune it had earned him, not through engineering failure, but through absolute faith in the wrong person. The same conviction that had once allowed Jack Parsons to imagine the impossible was now leading him somewhere that neither science nor engineering could follow. As the Second World War gave way to the Cold War, America's wartime alliance with the Soviet Union dissolved into suspicion. National security became an obsession. Scientists, engineers, and defense contractors who had once been celebrated for their ingenuity were now judged by a different standard. Could they be trusted? For Jack Parsons, the answer was becoming increasingly uncertain. His involvement with the OTO, his unconventional lifestyle, and his associations with individuals investigated for communist sympathies had already drawn the attention of federal authorities. As anti-communist paranoia intensified, and Senator Joseph McCarthy's investigations came to dominate the national conversation, Parsons found himself trapped in a country that increasingly viewed eccentricity as a security risk. The institutions he had helped build began closing their doors. His security clearances were suspended. Government contracts disappeared. The aerospace industry that had once depended on his chemical intuition now regarded him as a liability. Aerojet continued to expand. The Jet Propulsion Laboratory continued to grow. America's rocket program accelerated into the Cold War. But the man who had helped ignite it all was no longer invited inside. By 1950, Parsons was struggling to support himself. Desperate to return to the work that had defined his life, he accepted a consulting arrangement connected to the newly established state of Israel, which was seeking expertise in rocket propulsion. Drawing upon research he had helped pioneer and technical material he believed to be largely his own or already in the public domain, Parsons began preparing reports on solid rocket technology. Federal investigators were already watching. His correspondence was intercepted. His activities were scrutinized. Investigators seized documents and questioned whether he had improperly transferred sensitive technical information abroad. Although the allegations ultimately failed to produce an espionage conviction, the investigation itself proved devastating. In the climate of the early Cold War, acquittal was not the same as vindication. Parsons permanently lost his security clearances and with them, his place in American aerospace. The scientist who had transformed solid rocket propulsion could no longer legally contribute to the field he had helped create. It was a cruel irony. The Jet Propulsion Laboratory continued pushing outward toward the planets. Aerojet continued building the engines that would power America's future. The space age Parsons had dreamed about as a boy was finally beginning, but its forgotten architect could only watch from the sidelines. The man who had unlocked the chemical potential of the rocket was now a social outcast, barred from the laboratories and government projects he had helped bring to life. Once celebrated as one of America's most gifted rocket pioneers, Jack Parsons found himself surviving on the margins, mixing special effects chemicals for Hollywood productions, taking contract work wherever he could find it, and struggling to rebuild a life that had steadily slipped beyond his control. For the first time since he was a teenager, Parsons could no longer build the rockets that had defined his identity. Then, in June 1952, the story came to an abrupt end. An explosion tore through Parsons' home laboratory in Pasadena, reducing much of the building to rubble. He was just 37 years old. The official investigation concluded that the blast had been an industrial accident, likely triggered while Parsons was handling explosive chemicals. Others have since suggested everything from suicide to assassination. More than 70 years later, none of those theories has ever been substantiated. Whatever the cause, one of the most remarkable figures in the history of rocketry was gone. Jack Parsons never witnessed the space age he had dreamed about as a boy. He never saw Sputnik cross the night sky. He never watched the Jet Propulsion Laboratory grow into one of the world's leading centers of robotic space exploration. He never lived to see astronauts carried into orbit aboard the space shuttle, launched by solid rocket boosters built upon the same castable propellant principles he had helped pioneer. His legacy would live on in two very different worlds. One looked upward, to satellites, planetary probes, and human spaceflight. The other pointed across continents, placing the same technology inside the ballistic missiles that defined the Cold War. Like the man himself, the engine he helped create proved capable of both extraordinary creation and extraordinary destruction. Jack Parsons spent his entire life refusing to accept the limits that others believed were fixed. That refusal transformed American rocketry and helped lay the foundations of the space age. It also led him down paths that isolated him from the very future he helped create. History remembers the astronauts who reached space. It has almost forgotten the man who helped make it possible. The conquest of the cosmos has always belonged to those willing to imagine what others dismiss as impossible, and Jack Parsons imagined it first. Jack Parsons helped solve one of the greatest engineering challenges in history. The story of how that breakthrough reshaped the Cold War and ultimately carried humanity to the moon begins with the space race.